Hey everyone, how is everyone doing today? Good morning, wake up. Okay, so today we are getting into what a quadratic function actually is. And quadratic functions serve tons of purposes in the real world. So again, this is one of those topics where you can't ask me how this applies to the real world because they are literally everywhere. They're just probably not referred to as quadratic functions, but you're going to see the importance of them and how we can use them in the real world. So I don't think that it's something that you'll deal with on an everyday basis when you're an adult or now, but maybe if you do sports, it'll help you understand a little bit more behind the physics of it, or what your coach is trying to tell you. This, especially if you're playing like basketball or baseball, things like that, golf. So today, I'm going to lead you through a PowerPoint, so you have to bear with me. I cannot pause this video. This is the only way that I can record that it actually saves right the first time, but the only downfall is that I can't save it. I mean, I can't pause it. So you're going to have to deal with me as I go between screens here. So I'm going to present to you my screen, and I'm going to show you a PowerPoint, and it shows all of the things, not all of, no. It's going to show you some of the ways that quadratics are found in the real world. So I am going to present my screen. Just bear with me, please. Okay. Oh, lordy, lordy, what happened? Uh-oh. What did I do? Okay. Sorry. So hopefully you can still hear me. Okay. So I'm going to present. Okay. So this first slide says, what is a quadratic equation? And if you notice here, you have a guy or a girl who is juggling, right? And if you see, it goes up and down like that. So Galileo found that all objects thrown will follow a path in the shape of a parabola. Okay, so if you throw the ball from one hand to the other, it will follow in the path of a parabola. So here are some ways that parabolas are found in nature. So as you see, the dolphins, they jump out of the water and then they return to the water. So that makes a parabola. Parabolas are in architecture. So when they're making the bridge, this is a parabola. Okay, the wires, or I don't know the technical terms for that. I'm sure there's tons of your parents or brothers or sisters or aunts or uncles that know the terminology. I don't. But this part of the bridge here that connects to these uprights, that's in the shape of a parabola. Parabolas for fun. When you go on roller coasters, this is the shape of a parabola. There's actually a ton of algebra that goes into designing theme parks, and especially roller coasters. There's a lot of science and there's a ton of math. So roller coasters, those are in the shapes of parabolas. Also, when you skateboard, you go off of a ramp, you jump, you do your little kick flips or whatever that's called. When you go up and you come down, that is in the shape of a parabola. this girl is playing volleyball. So when she hits the volleyball, it goes in the shape of a parabola. So how are quadratic equations used in the real world? So we talked about parabolas, right? So do you see this basketball? It is going in the shape of a parabola. So if you haven't gotten that yet, the parabola is like this curve type of shape. Okay, so a quadratic equation is actually the measurement for that path of the parabola that the basketball is traveling on. So that's a quadratic equation there in that shape of the parabola. Okay, so that basketball follows a quadratic equation that outlines the parabola in which the ball is traveling. Okay, so the graph of a basketball shot shows the distance and height of the ball as time passes. So let's look at that on a coordinate plane. So you have your time or your x-axis here, and then you have your height. So the x-axis represents the distance or the time, depending on what you're looking at. And the y-axis represents the height. Okay? X and Y are usually changed to letters that represent these types of measurements, so H or T. So if you think about it, a parabola, right, for that basketball would look something like this, where when the ball reaches its peak, right, that would be like the very top part before it starts to come back down into the net. Okay, so hopefully that helps you understand a little bit what parabolas are useful for and how that relates to quadratic equations. So hopefully that makes sense to you. So when you see that shape, right? So like the dolphin, if this is the water, the dolphin jumps out of the water, it reaches a peak, and then it comes back down into the water. That shape is called a parabola. And the quadratic equation takes you on that path of the parabola. Or the quadratic equation, if you're looking at a graph, can graph out for you where is that peak, right? And how much time is it going to take for you to get to that peak? And then how much time before you come back down, okay? So that hopefully can show you and open your mind up to all these different ways that quadratics and parabolas are all around you in the real world. So what we're going to do now is I'm going to show you the actual graph of a parabola of the parent function for a quadratic. And we're going to talk about some of the key features. So this is important for you to know before we start to solve quadratics, because you need to understand what each part of the quadratic represents. So when we solve it, you know what that purpose is for. Okay, so you have to understand the parts of a quadratic before we can move on. Okay, so I'm going to turn my document camera on in 1 second. We're going to update our table of contents, but I just want to clarify. So after this, after today's lesson, what you're going to do is you're going to think about where do you either use parabolas in your life, maybe not while you're in quarantine, unless you throw the remote to your brother or your sister while you're sitting on the couch. But before we were in quarantine, how were you, or where were the parabolas in your life? Okay, so I don't want you to use any of the examples that were given in the PowerPoint. So dolphins jumping out of water, bridges, skateboarding. Sorry, I took that one off the table too. Basketball, no go, guys. Sorry. And volleyball. So all of those examples that I gave you, you're not able to use. And sorry, Lainey, I'm going to be using figure skating in my example on Flipgrid. So Lainey, sorry, honey bunnies, you can't use that. So think of another one. Okay, so let's talk about the structure behind a quadratic function. So I'm going to turn my document camera on and open up to my table of contents. Oh, sorry, we're backwards. Okay, so we talked about multiplying binomials last time. So today we are adding in, I don't know why, you guys, I am on the struggle bus. I don't know why that says 72. I put the page number there and there. I don't know. So what is a quadratic function? On my page 72. This should not take more than one page. So once you're done with that, go to your page 72 and title it, What is a quadratic function? Okay, so I think the best way for us to do this is actually if we turn our notebooks so we have it this way. Okay, so it just gives us more of a space, I guess, to write like this way. Okay, so the first thing that I want you to please draw is a coordinate plane. So let's draw the coordinate plane. Okay. So there's your coordinate plane, your x, your y axis. And then just okay. So we just need plus and minus 1 to 2. So the next thing we're going to do is we're going to put a dot or a point on the vertex. And then at positive 1, we're going to go up to 2. No, sorry, positive 1, we go up to 1. Positive 2, we go up to 4. And then the same thing over here. Negative 1, 1, negative 2, 4. Okay. So now this is all rounded because we're making a parabola. And it goes up like that. Okay. So as long as it looks similar to that, it doesn't have to be perfect. So the shape of a quadratic function is called the parabola. Okay. So that is called a parabola. So the basic general formula for a quadratic function. So if you want to say general form for a quadratic function is you can have f of x or you can have y. So either one, f of x or y equals a x squared plus bx plus c. So ax squared plus bx plus c. That's your general form for any quadratic. Okay, so your a, your b, and your c, those are all can be any type of integer. Okay. The parent function for a quadratic is f of x or y equals x squared. So this is the parent function, and that's what we drew over here, right? Because if I put in 1, 1 squared is 1. If I put in 2, 2 squared is 4. If I put in -1, -1 squared is 1. If I put in -2, -2 squared is 4. Okay? So we've identified the general form. I'm not going to go through and tell you what A, B, and C all represent yet, because that will be more relevant when we're graphing. And before we graph, we have to actually solve quadratics. And that's going to take us a little while. So I'll go through a little bit later on what A, B, and C, what they represent for the graph and for the function. Okay? So let's talk about some of the characteristics of the graph. So we have some characteristics. So we have a vertex. So that vertex right here, this is your vertex. That vertex is going to tell you a lot of things. It can tell you if your graph has a maximum value. So your vertex is either the maximum value, and that's the y value of your vertex. So if you think about a maximum value, it means it's the highest value that graph can have. So if you have a maximum value, your parabola is going to open downwards. Okay, so keep in mind, this is just an introduction. And as you know, I always tell you, it's going to be confusing at first. And since we're not going to be really using any of this right at this moment, it might not make sense to you or be applicable. But hang in there with me. I will wrap it all up in a nice bow for you by the end of this unit. Okay, so it can tell you the maximum value, or it can tell you the minimum value. So the minimum value is the lowest part, right, of the graph. And that's what we have here. So this vertex, this point right here is not only your vertex, it's also your minimum. So that y value there is the graph's minimum value. Your vertex is also going to help you identify your range. So I don't know if you want to say like helps identify the range. Okay, so for example, this graph, the range would be y is greater than 0, because your minimum value here is 0, and it's a closed circle, so it's greater than or equal to. So our range for this parabola, well, let's talk about the domain. The domain, as in all graphs that we've been doing, is all real numbers for this graph. The range is going to be y is greater than or equal to 0, because your parabola is opening up. So that's the lowest point on the y-axis that your graph will ever be or could ever be. Okay? All right, so we have the parent function. We have that it's called the parabola. We have the max and the min and the vertex. So I talked about how next what we're going to do is we're going to learn how to solve a quadratic. Right, so we did the general form. We did the characteristics. So now a big feature, or a big deal with quadratics, if you will, we're going to talk about how many solutions and what that means. So, the solutions, AKA, you need to be able to use these interchangeably. Solutions are also known as let me spell correctly, the zeros of the function. You're like, great. What the heck does that mean? So when you solve a quadratic, you are finding the zeros for that function. Awesome, Mrs. Greenway. What does that mean? Very good question. This is where the graph or the parabola crosses the x-axis. Okay? So where the graph is going to cross your x-axis. So now you can see why this is important to know before we graph it. We have to know how to solve it because I need to know where is this graph going to cross my x-axis. So that's like taking your general formula or whatever quadratic you're given and you set that equal to 0. Okay? So when you're solving it, you're finding where the graph crosses the x-axis and you're setting, so we can say set the equation equal to 0. So you'd have your ax squared plus bx plus c equals 0. And these would be numbers. And then we learn how to solve that. Okay? So we talked about what the solutions mean. Let's talk about how many solutions. So kind of like a little bubble off of this has its own little cloud. How many solutions? So, how many solutions? A quadratic equation can have 3 different types of solutions. So when you're solving it, right, and you get an answer, you can have 2 solutions. I need a new color. So you can come up with 2 solutions. And that means that the graph is going to cross your x-axis twice. So that would look like if this is your x-axis and this is your y-axis, your parabola could look like this. Right? So it crosses through there and it crosses through there. And what you found were what those x values are where your graph hits the x-axis. So that will help you make your parabola. Okay, so 2 solutions means your graph is going to cross your x-axis twice, and that will help you graph it. Okay, so 2 solutions. We then have 1 solution. One solution means it sits on the graph. It sits on your x-axis. So one solution means that your vertex is on the x-axis. So our parent function sits on the x-axis, and so therefore this only has 1 solution. So if you get 1 solution when you solve your quadratic, that's going to give you your x value of your vertex. Okay? And then we have something called no solution. For now, algebra 2, you will have to figure out the solution, but for now, we have 0 solutions. What that means is that your graph never crosses your x-axis. So if you had like a coordinate plane here, that's like if your parabola was way up here like this. See how your graph doesn't cross your axis? And you have imaginary roots. So no solution. The graph never crosses the x-axis, and you have imaginary roots. And in algebra 2, they're going to go over that with you. But for our sake, that's like if you had the square root of negative 81. If you did all of your math out and you get the square root of negative 81, that means your graph isn't going to cross your x-axis. It's going to be sitting in one of the quadrants, or a combination of 2 of the quadrants, just not hemispheres, if you think of it that way. But it would have imaginary roots that sit above the axis. We don't need to go into that. You just need to know that if you come up with something like this, the square root of negative 81, there is no solution. This doesn't exist, right? The square root of negative 81 does not exist. So that's a lot, right? And this is why I wanted to take just one day just to kind of introduce this to you. You just need an idea of what it is. And what we're going to be focusing on is the solutions for right now. We're not going to be graphing. We're not going to be talking about a vertex. We're not going to be talking about a max or a min. We're just going to be solving the quadratic. And by solving the quadratic, I just want it in the back of your heads that when we solve the quadratic, we are finding where your parabola is going to cross the x-axis. Okay? So hopefully this made some sort of sense, like where you're like, oh, okay, I know what a parabola is now. That's okay. That's all. That's where you need to be for right now. Next week, we will get into solving quadratics. And even at that point, you just need to know how to do the math. And by the end of the quadratic unit, you're going to be pros at what all of this means. Okay? You just have to trust me. I will get you there. All right. So go make your flip grid. Hi, crazy. She learned how to open doors recently. Isn't that fun? So go make your flip grid talking about where you will see, or where you see, parabolas in your everyday life. If you have questions, A, don't freak out. B, You're not really supposed to have a great understanding of what any of that means, what I just talked about. You just need to know that a parabola goes up and down. It has a vertex. It's symmetrical on each side. That's really all I need you to know right now. Okay? So go make your Flipgrid, and we are going to chat today for our check-in. We're going to chat at 1. Okay? All right, guys. I miss you. Have fun, and I will see you soon. Bye.